Dear students, today our topic is linear search. This topic I'm planning to cover today. In today's lecture, I will start off with giving some examples. That's why I have arranged these books in a chronological order. So I will try to give you some examples, and after that we will get into the algorithm so that you understand this one better. If you walk into the library, your university library, and if you try to find a book in the shelf, what is the first step you're going to take? What is the first step you are going to take? You will search your desired book one by one from shelf number 1, from the very first book, right? So in this case, I have arranged 4 books. The first one is a book on electrical technology. The second is another book on religion. The third book is on TOEFL preparation, and the fourth one, it's a book on motivation. So if I just tell you to find out the TOEFL preparation book, it's very easy for you to look at this one and identify this one within a minute. But what happens if you have hundreds of books arranged together? Let's say you have thousands of books. In that case, what will you do? Will you start looking randomly, or will you start from the very beginning, let's say from book number 1, and you will just try to find that one out? So what I'm trying to tell is, if you have 1,000 books arranged in a shelf and you are being asked to find out the TOEFL book, in that case what will you do? You have 2 options. Either you can look for that book randomly, or you can start off with the first book and check whether it's a TOEFL book. Next up, you need to go to the second book and find out whether it's a TOEFL book or not, and so on, right? This is one way of finding it out. So the same thing is being done in the linear search technique. Now we will get into the algorithm. Now let's look at the algorithm. So I have already showed you some real life examples. Now let's look at the linear search algorithm. So the definition goes like this. So linear search is a sequential search is made over all items one by one, right? We are just searching sequentially over all the items one by one. That actually means we start off from the very beginning. We try to identify our desired thing from the list. So this is how a linear search goes. So this is the algorithm for the linear search technique. So this one, I is equal to 1, I equals to 1. It can either be 0 or 1. It actually depends. We will talk about this later on. Let's say we have this given example and we are being asked to find out 16 from the list. What is 16? 16 is our desired number. Or in other case, it can be considered as a book, right? From the previous example, let's say this 16 is a book and this is our shelf, right? These boxes are different shelves. In these different shelves we have different values. These values can be compared, not compared, you can say these values can be understood as books. We have different books here, this one, this one, this one. These values denotes different books. So we are being asked to find out this number 16 from this list. So what will you do for this case, for finding it out? We'll talk about this. So here we have, as you can see, we have some numbers also here, over here, 0, 1, 2, 3, 4, 5, and it goes till 7. What are these? These are actually a list of numbers. This is actually, you can say it's a place value, or you can say this is the number index, or you can say place value or index, whatever you want to say, it's okay. It's either we call it index, sometimes it is called as place value of what? Of an array. These shelves, these different segments can be called as array, right? And this is denoted with I, right? Usually it is denoted with I. So here, instead of writing I is equal to 1, in our case, no, not 1. In our case, we are starting off the value I is equal to 0. So if I tell you to find out, not find out, let's get into that one later on. Just let me write this thing down. A of 0, this actually means A of 0, this one, this 0 goes into a third bracket, and on the left hand corner we have A, that means index 0. So at this point we have which value? 4, right? It goes like this. Okay, but we'll talk about this also. In point number 2, I have written that we start off with I value is equal to 0. Let's say we start off with I value is equal to 0. Then if I is greater than n is what? In this case, what is the value? What is our n? This is our maximum value, or max value, or you can say maximum not value, you can say maximum size of the list, right? Maximum size of the list is denoted with n, right? So if I is greater than n, so in our case, when I is greater than n means 8, when the I value becomes 8, it will obviously be greater than 7. In that case, we need to go to step 7. What is our step 7? This is our step 7. We need to print element not found, right? We need to go to this step. Okay, and then we need to follow this. But in the third third option, we have if A of I. So there is a if condition, right? If I is greater than n, we need to go to step 7. Otherwise, we just need to follow the instructions chronologically. That actually means we need to do this first task, then go to second task, then the third task, and so on. If I is greater than n, in that case only we need to go to this place, step 7, and follow this one. Otherwise, all the calculations has to be done chronologically. So here we have A of I. If A of I is equal to x, then you need to go to step 6. What is our step 6? So there are two things you need to understand. What is x, right? We have seen A of I. What is A of I? We have understood this one. A of I is nothing but the values inside that array. And x, what is x? X is nothing but the value that we are supposed to find out. In this case, x is 16, right? We need to find this thing out. So, right, if A of I is equal to x, we need to go to step 6. Step 6 is this one, right? Then in step 4, I have written down that we need to increment the value of I. I should be equal to I plus 1. Then we need to go back to step 2 and follow the steps. So maybe this algorithm is a little bit confusing for you. Let's take this example to simplify this one. So as I have told you before, that we need to figure out this x value of 16, right? We are being asked to find out this 16, or figure out or search for this 16 from the list. So what is the first step we need to take? First, we start off with I is equal to 0, right? And I is equal to 0. Then if I is greater than n, In our case, n is what? N is what? N is 7, right? Isn't it? In our case, n is 7. So this is not applicable. We follow this one. We go to this one. So now a of I, if a of I, in this case a of I means a of 0. At a of 0 place, this is called actually a of 0, a of 1, a of 2, like this. Okay, so at a of 0 we have 4. Is it equal to x? X is what? 16. Is it equal to x? No, not really, right? So we don't have to go to step 6. We need to follow this one. So following this one tells us that we need to increase the value of I. So now we have I equals I plus 1. Previous value of I was 0. Now plus 1 gives us 1, right? Now we go back to step 2. This is our step 2. So now if I is greater than 1, go to step 7. I in this case 1. Is it greater than 7? No. Then follow along. So now we have a of 1 equals to at a of 1 place we have 5. Is it equal to 16? No, not really. So we need to go downward once again. Here we need to increase the value of I. So now previously we had a value of 1. If we increment the value in this place, it will become 2, right? We go back to this step 2 greater than n? No. Then a of 2 is at a of 2 place we have 10. Is it equal to x? Not really, right? So this is how every time the value of I, it's getting incremented, right? A of 2, then it will become a of 3, and then it will become a of 4. At a of 4 we will be having 16. At a of 3 we are actually having 12. Is it equal to 16? No. At a of 4 we have 16, right? It serves our purpose. Now we need to go to step 6. Step 6 is which one? This one, right? We need to print element x found at I. So we need to write this one. Print element, in this case x is 16, found at the value of I is 4, right? Print element 16 found at 4. Then what's next? Then after that the execution, the exit part should be done. So this is how the linear search works. Linear search is a very basic search. There is another thing called binary search. There are some limitations in linear search. We will see the advantages and disadvantages of both of the search in our next lectures. I hope you have understood this topic. Now I will ask you to do an assignment problem. You try to solve this algorithm. Not solve, I would say you try to use this algorithm and write your own code in C language and send it to me. I will try to find out your problems over there. So I hope you have understood all the things. In the next lecture we will talk about binary search. Till then, goodbye.